there is 22 types of sorry 24 types of instruction we have. One is first we are going to the bit instructions. There is alarm instruction is also there, but right now we are not using that alarm instruction. Then we'll just go through the bit instructions. Can we go through Guru sir, can we go through some details or just overview if it requires for the instruction? I think yep. Okay, okay. These are the bit instructions. This XIC, XIO, OT. We can see the long form of them in the manual. XIC is the enable output when bit is set. XIO when output is sorry enable output when bit is closed. You can read the description in the manual and you can go through the one by one. We will just go through the just overview of these instructions. ONS, one shot timers, then OSR, OSF, OSRI, OSFI, then there is some how to use, where to use, and which controller support for this instruction. That all details are given below. The controller names, like controller series, and which language support for that particular uh, bit or that instruction, that also mentioned here. The ladder diagram also support for this instruction is the XIC function block is also support this XIC. Not in the function block there is no this XIC instruction, but in ending like that you can use in the function there is no available. In the structure text not available. This bit instructions only available in the ladder diagram. Then data types of that instruction is boolean. In the whatever instruction we have seen here, all are the boolean data types, but in the one ONS instruction we can select different data type also. We can create the arrays, integer array like that. Then XIO, the symbol is like that, not supported for the functional structure text. Then ONS, the ONS instruction makes the reminder of the running true each time run condition in transitions from the false to true. It works only one time when the transition happens from false to true. You can see the examples. There is a limit switch and ONS instruction. You can how much time you operate that limit switch that you want to count, then you can use the ONS instruction and you can count that all the actions or how much time it operates, that you can count into the add, or you can use the counter also. If you have any operation, then you can use the counter. Most of the time this ONS instruction used for the counting, adding, or the one-time operation. For that purpose the ONS instruction is used. Then one shot falling, it works reverse. The OSF instruction sets the output bit for one scan when run condition in transition from true to false, and ONS is works from false to true. It works reverse, this OSF instruction. it has some functional block, but ONS instruction doesn't have any function block. This instruction is not available with the function block and structure text. The data type is boolean. You can use the OSF as a output also, and that output of that instruction you can use for the counting here. One shot falling with the input. Yeah. Studio Enterprise. Studio Edition. You need to install a Studio Edition. Okay. You can you go through the video? In video there is a clear idea I have given. If you miss some steps, then it will be difficult at the time of data logging or reporting. Then uh-huh. Yeah. Mhm. Cycle, cycle, cycle is different. Yeah. The OSF instruction sets the output bit for one execution cycle when the input bit toggles from false to true. Okay. The OSF block, the input and output. You can see the example how we can use this. OSF instruction is available with the function block and structure text. In the structure text we can use as a OSF the instruction number is 0 1 or whatever instruction number we have. Then input bit, this is input bit dot input bit, that parameter you need to access, you need to put that parameter after the instruction name, and the separation is the dot, the separation is for the dot, and we can assign the limit switch to this input bit directly by using this structure text instruction or the syntax of that. And you can end with the OSF and OSF 0 1 and output state. If you want to hide the output state, that output state you can assign to your tag. If this is your tag and this is your instruction tag, you can directly assign to it. This is actually your instruction instruction shortcut name, and this is your tag name for that instruction. Then the OSR one shot rising, the OSR instruction sets the output bit for one scan when running condition in the transition the false to true. You can see the example OSR. You can use that output bit here, and you can execute your addition or countdown or like that. This is why OSR is instruction is there. OSR instruction sets the output bit for one execution cycle when the input bit toggles from the clear to set. Then OTE instruction is the output data bit instruction. OTL is the latch. OTL instruction let's latch the data bit, and OTU is the unlatch of that data bit. Here it for the OTL and OTU we have same tag name for the OTU and OTL, because the same tag we are going to latch and same tag we are going to unlatch. One also you can use the OTE instruction, but when you are going to use OTL and OTU, that same in the same routine you not able to use the same OTA and OTL instruction, because it creates some conflict between the latching, unlatching, and continuously on by some logic. If this is not the rung is not true to on this bit, then your OTL and OTU can work, but when your data bit also going running and OTL and OTU also going running, it will create some conflicts. Then we are going to see that some timer instructions, timer and counter instructions. In the timer and counter instruction, we can see the T on, T off, RTO, CTU, CTD, and RES reset. Uh, this instruction is supported for the functional block and the structured text, and for the ladder is the T on, T off, RTO, CTU, CTD, and reset. For the functional block and the structure text, that instructions uh, available as T on reset, T off reset, retentive timer reset, and countdown, count off and countdown. This is the combination of countdown and count off. Here in the ladder there is a separate instruction for the count off and countdown and reset, but here the all the timers it club with the reset tag, and that reset button you can configure any tag from the external, and you can reset timer or counter, or otherwise you can disable that counter and you can reset that counter and timer from the input enable. Then we can go one by one. This is the time. uh, Here you can see the detailed description or the description for this instructions. We are go directly the countdown. All of you know about the countdown, count off, count CTUD, then reset instruction. This reset instruction we are used for the timer reset or counter reset. We are using that reset instruction. RTO is the return to timer. All of you I think know about the return to timer. Guru sir, I think all of you know about the return to timer. Okay, okay. um, Nikita, I will, yeah, I will, okay, I will just explain this in 1 2 3 4 lines. The retentive timer instruction is a retentive timer that accumulates time when the instruction is enabled. इसमें क्या होगा, आपका जो रिटेंटिव टाइमर है, आपने एक इनपुट ऑन किया, ठीक है, तो जितने टाइम तक इनपुट ऑन रहता है, सपोज 10 मिनट तक आपका रिटेंटिव टाइमर और 10 मिनट का काउंट करेगा. अगेन यू स्टॉप द इनपुट एंड आफ्टर 15 मिनट यू स्टार्ट द इनपुट अगेन, then it start from that 10 minute and it will counting that remaining time. That is the functionality of retentive timer. Then retentive timer on, there is a two this is retentive timer on, and this is retentive timer on with reset. There is a one uh, reset bit is there for to reset the timer, retentive timer. Then t off timer, it's only for the ladder. Then t of r is only for the functional block and the structure text. The t of r instruction is the non-retentive timer that accumulates time when the timer enable and is cleared. When the input is gone, then your accumulated values also reset automatically. Otherwise, you can use the reset button to reset that timer. Once your timer is done, you need to reset this timer by using this reset bit. That's why uh, that name is the t of r or t on r. This is t on r. I will just go without. There is some usability functional and one logic diagram is also there, how it works. Then input, enable the timer, then preset the timer, reset bit. This reset bit is always the boolean bit. Then accumulator value, you can see it here. Then your done bit timer. Then input output. These are the system instructions. This instruction we can use with the ladder diagram and structure text. This instruction is not available for the functional block, which is the message instruction, GSV and SSV and IoT. We can see that some description. MSG